Hi everyone, welcome to my channel and you're listening to Subhash Chandran. In this video, we are going to discuss about pipe routing fundamentals. And this is going to be a part 1. So I'll be putting part 2, part 3 to cover more information about pipe routing. Moreover, in this video, I'm going to cover the major requirements based on which pipe routings are always done, not only in one industries, across the world in all other industries. These are the major requirements based on which the pipe routing is generally done. So if you are able to understand these requirements, you will be able to deliver an excellent routing in your design. So without wasting time, let's get into the video. And before getting into the video, if you are a new viewer, kindly give me a subscription because nothing excites me more than your subscription. Because this is the only motivation factor that I have to put more videos and to share more of my knowledge with you. So without wasting time, let's get into the video. Pipe routing. Pipe routing is one of the major activity in piping design and it is as important as other engineering activities in the project. You know why it is? Because excellent pipe routing is something that solves 50% of the issues of layout development. If you are able to deliver an excellent pipe routing, that will minimize the engineering activities required to develop a wonderful layout. So routing is actually a skill, but it cannot be gained in a day or a week or in a month actually. It has to be gained through experience, working from different projects, working in a different piping system, working in a different process system, and working in different parts and areas of the layout. However, the fundamentals of pipe routing always remain same irrespective of the type of piping system or the country or the state or the industry. So what are those fundamentals? That is what I am going to share with you in this video. There are 7 key requirements to be complied while planning for a pipe routing. If you are able to incorporate and address these 7 key requirements, you will be able to deliver a wonderful and excellent pipe routing. So without wasting time, let's see what are the 7 key requirements. Let's see the first requirement. The first requirement is the pipe routing should ease the process. What does it mean? It means that the pipe routing should support the process flow in order to conduct certain process operation. So in a simple term, let me tell you, it is nothing but the flow that takes place inside the piping to be able to travel and to complete the cycle as planned by the process engineers in P&ID and PFD. So let's understand this from the example actually. Case 1, we have to avoid unnecessary loops. So how to avoid unnecessary loops? Let's understand the P&ID. So in this P&ID, you can see a line that is traveling from a drum to the pump. This is a gravity flow. In a gravity flow, the line starts from the higher elevation and goes to the lower elevation. So let's see what happens if we put an unnecessary loops actually. See, this is the unnecessary loops that I am talking about. If we are going to make a piping this fashion, the line will not have sufficient pressure to pump the flow. So what happens is that, so in this here the flow will be stuck and the pump will not receive the enough suction. So this will disturb the entire process scheme. So we should not route the piping with unnecessary loops. So what happens if we are going to route the piping with unnecessary loops? It is going to increase the static head and disturb the entire flow volume and the flow rate basically. So how do we have to route it actually? We have to route it and comply with the gravity flow. This is how we have to route it actually, because since this is a gravity flow line actually, it should not be routed to a higher elevation than the starting point actually. So if you are going to make a routing in this fashion, your routing will be perfectly support the process condition. And then we have a case 2. What is case 2? Case 2 is that here we are trying to avoid the number of elbows. How to avoid number of elbows? Let me show you a typical example. See, this is a line with a multiple change of direction. Each change of direction has an elbow actually. Let's count how many number of elbows we have. 1, 2, 3, 4, 5, 6 and 7 elbows we have actually. So how to reduce the elbow? See, you have shown in the red line. The line has traveled the same distance but it has with a lesser elbows. Now how many number of elbows we have? 1, 2 and 3. This is how we have to make the routing very simple. We should not make the routing too complicated, because too complicated routing increases the material and it will disturb the flow condition, because the pressure drop is always higher in the elbows because of the change of direction in 90 degree. So excess elbows will decrease the system pressure and stops the flow. So these are the 2 important examples that you have to remember while routing a piping in order to ease the process. Let's see the second requirement. The second requirement is your routing should ease the accessibility. What does it mean? It means that Routing should allow access to all equipments, valves and instruments to perform daily operations. So let's understand this from an example. See, this is a picture that shows a person is operating a valve, which means that the person has an access to the valve. What if the valve is placed at much higher elevation? He may not be able to access. So this is what you have to remember while making a pipe routing. All the valves and instruments should be in an accessible height and should be in an accessible place. Let's see another example. In this example, you can see a drum and a pump wherein both are connected with a piping. But the piping is made in a certain fashion to allow a certain access. What is an access? The access is given over here. It is for operator access, which means that this particular space is reserved for the people movement, so that the operator or any worker or any representative in the plant or in the system can walk below the line. If the line has been routed at this height, they will not be able to walk around the piping or walk around the pump system actually. So while making a pipe routing, and we should also remember that we should not block any access, we should give more access for the equipments and pipings and instruments and valves. Let's see the third example. In the third example, we can see a series of control stations installed in a plant. But what we have to observe over here is that the clear access has been provided. Clear access has been provided to do a maintenance for this valve and to access this valve and access the utility stations. This is how we have to route the pipe actually. So when we are making a pipe routing, we should always keep in mind that accessibility for all the instruments and connections needs to be provided. Now let's see the third requirement. The third requirement is pipe routing to ease maintenance. What does it mean? It means that the pipe routing should not be an obstruction for maintenance activities such as removal and reinstallation of equipments, valves and instruments. In a process plant, there are some equipments, valves and instruments needs a regular maintenance. In order to do a regular maintenance, there should not be any obstructions to access these equipments, valves and instruments. Let's understand this from an example. This is a picture showing a series of heat exchangers installed, and there you can find the space reserved behind the heat exchangers, and also there is a space reserved in front of the heat exchanger. This is for removing the bonnet head, and this is for removing the tubes which is within the heat exchangers actually. So moreover, and more than this space, there is also a space reserved for maintenance access. This is for the vehicle to come in and pick the tubes and go. Vehicles such as forklift and small cranes could be. If this space is not reserved, and the vehicles, how do it can access the tubes, and there will not be any road access. So basically there must be an access for the vehicle to come directly to these equipments and to shift the materials and to bring the materials and all actually. Let's see another example over here. Here, and from this picture you can see there are drums. There are multiple drums over here, and there are pumps over here. In order to do a maintenance for these pumps, the drums should be in a position to be able to lift through cranes actually. Imagine that we have laid a piping over here, over the drums and over the pumps. So in this case, and it is evident that these drums cannot be removed until and unless these pipes are removed. So this is the clear obstruction. So we should not route a piping over an equipment in such a way that it obstructs the maintenance activities. So how do we have to route it? We have to clear the space for the maintenance activities. Now, right now, this drum could be shifted because there is no obstructions on top, and here also you can see there is no obstructions on top of the pump, so that it could be removed. It could be shifted, it could be removed from its location basically. So in case where the suction with the piping has to go on top of equipment, we should provide a brake flange. So why this brake flange is provided? Because in order to remove this drum, they can remove this brake spool and they can remove the drum. This is another fantastic example. Now let's see the third example. This is an elevation view of showing a vessel and which has a connection from top, the piping that starts from top and runs all the way down to the grade actually. So here the point which has to be noticed is that here we have a manhole. Manhole is the nozzle opening that is provided in the pressure vessel in order to do a maintenance, in order to do flushing, cleaning or any kind of maintenance activities inside the pressure vessels. So what we have to observe over here is that here the line has been taken from the top nozzle and routed in front of the manhole. So how do we is it possible to open the manhole now? So from this plan view you will be able to see that this is the door opening of the manhole. So in case if the line is routed in this way, the doors cannot be opened. So there is this is a clear obstructions for the maintenance activities. So how do we have to route the line? So in order to route the line in such a way that it should not obstruct the maintenance activity, we should shift the position of the piping in such a way that it gives a clear access to the maintenance door or maintenance activities basically. So this is the third picture that shows the piping has been shifted and routed in such a way that it also gives a clear access to this manhole. Right now they can open the manhole nozzle and they can do any maintenance activities inside the vessel. Now let's see the fourth requirement. The fourth requirement is to provide safety for the personnel who are working in the plant. So what does it mean? It means that the routing should not create an unsafe situation for activities such as the daily operation, construction, monitoring and inspection activities. Let's understand this from a picture actually. The first and the foremost thing to be provided as to improve the safety factor is to provide a headroom clearance. Headroom clearance for all accessible areas like platforms and grades and for all the accessible areas basically. So the operator or the worker should be in a position to walk in such a way that his head won't be hitting the piping. So from this picture you can see that the clear accessible space of about 2.1 meter has been provided in order to avoid any accident such as that, like while a person is walking below the line, his head should not hit the piping. So this is the very important aspect of the providing an access clearance, headroom. This is known as a headroom clearance. Let's see the other example. The second example is do not route pipe in front of stairs. The reason why is that when during an emergency, if a person has to rush and climb up or climb down, if the line is in front of the stairs and he may go and hit the line and it may injure his head or anything could happen actually. This is one of the reason why you should care while routing a piping and whether you are routing because stair is a clear access way. So you should not route a pipe in such a way that it obstructs the access actually. All the accessible area or pathway or walkway or any stairs should have a clear access for to go actually, otherwise and it will be a safety concern. And the third example is that design for a safe operation. Let's understand from here. Here we have a platform and there is a operator standing over the platform to operate a valve. Say now imagine that we have routed one more line over here. So how do an operator can access this valve? So operator has to come over here to access this valve. Since the distance is not sufficient enough for him to access, he has to lean in front in order to access. So there are chances that possibilities that he may slip or he may fall down from the platform that could really cause a big damage to his health. So this is one of the important thing that you have to remember while making a pipe routing. So how do we avoid such scenarios actually? So we can avoid such scenarios by giving an alternate solution for a routing. So in this way, if we can route and we can provide an accessibility, clear accessibility, so that the operator can comfortably do any operations in the plants, or he can do a maintenance over the plants. So there will not be any obstructions. So common like if you lay the line on both sides of the platform, so it could be easily accessible. So in this way we can improve the safety of the personnel and improve the safety of the plant actually. Let's see the fifth requirement. The fifth requirement is to have a clear aesthetic look. Basically the routing should be done in a way that it gives good aesthetic appearance and great visibility of the plant actually. Let me show you some of the pipings and let me show you some of the design actually. This is the clumsy piping. You can see from this picture that the line is routed in a different locations with now a different number of supports, and moreover it occupies the entire area. So what if this line could be little more organized and little more arranged in order to give a better look actually. So the excellent pipe routing will actually looks like this. If you study the line and understand whether it could be arranged in a much more in a well mannered actually. So this could be this could save the space, and it could save the engineering activities, and moreover it could save the cost basically. So this is in this way you can give a good aesthetic to your appearance. I'll also show you one of the 3D the picture of I mean the plan view of the 3D model. From this picture you can exactly easily identify which are the equipments and how many number of lines are there and where the valves are installed, how it is installed. It gives an organized look, it gives a good aesthetic, it gives a visibility to the plant actually. So when we are routing a pipe, and we should always imagine that it should give a clear visibility and it should also have the good aesthetic look basically. Now let's go to the other requirement, which is the 6th requirement, which is a very important requirement, which is to save the cost. We should always save the cost, because cost is one of the important factors that drives the project actually. So best routing is always the routing where less numbers of pipes and pipe fittings are used. Unnecessary use of materials increases cost. So how do we save the materials? This is what it is. So first of all, we should always see there must be a minimum use of, the minimum use of pipe fittings. How? As I told you in one of the previous requirement, we should use minimum elbows. But there I have indicated using minimum elbows to increase the process flow condition, to ease the process. But at the same time, it will also save the cost of the overall project actually. If you minimize the number of fittings, definitely it is going to save the cost not only in terms of material, in terms of engineering activities, such as it will reduce the welding joints. So the number of welding joints will get reduced and the cost of welding joint also will get reduced. So from this picture you can identify the same routing has been made, but in this routing the number of elbows are high, but in this routing the number of elbows are less. In this way you can minimize the cost actually. So now let's go to the 7th requirement. The 7th requirement is the routing should be done in such a way that it should be able to be supported actually. See, if you are making a routing which cannot be supported, then there is no use of it actually. So whenever you are making a routing, it should be planned in such a way that it should be supported properly, because if it is not supported properly, and it's going to be an unsafe scenario. Now let's understand this with a picture. Now imagine from this elevation view, and we can see a vertical tall elevated pressure vessel, and from the top of the pressure vessel the line has been taken and connected on top of the drum. Let's consider the height of the pressure vessel is 16 meter and the pipe has been routed around 20 meter. Imagine that if this is the condition we are making in making a drawing and giving it to a contractor, is it possible to provide an engineering support? And even if we are trying to provide an engineering support, how much height it is? 20 meter height. Structural support needs to be placed at 20 meter height, which is not practically possible. So how do we have to address this actually? We have to route in such a way that the support shall be taken, and the cost effective design. Support should also be taken easily from the nearby grade or nearby equipments or structures, and at the same time the cost of the structure should not go high. How we can do this? And we can do this in this way actually. If we can route in such a way near to the equipments, we can take some supports from this tall equipments. These equipments are known as the columns or tower or any distillation columns. There are different names given for this pressure vessels and different process conditions basically. So if we can route the line near to the equipments, we can always take support from the equipment. And if we can bring the line near to the grade, and we can take the supports from the grade, so that the elevation, the height of the structural support could be reduced, and moreover the line could be properly supported. So this improves the safety of the plant, and it improves the overall the stability of the line, it improves the process condition of the line. So this improves everything actually. So in this way we have to this is the way that we have to route the line. So the 7 requirements that I have listed over here, if you can capture and understand these 7 requirements and apply this principle when you are routing a pipeline, most probably you will be able to deliver an excellent routing, the fantastic routing that can fit into your design basically. So I believe that this video will be very helpful for you to understand the basics of pipe routing. And really thank you for watching my videos, and thank you for supporting me. If you really like this video, don't hesitate to give me a like, and also don't forget to share with your friends. And moreover, if you are a new viewer, once again I request you to give me your subscription, because Nothing actually excites me more than your subscription basically. If you can get more subscribers, and I feel like a lot of people are interested in listening to me, a lot of people are interested in learning, so I'll be able to share the more materials and more good information that will be very helpful for you actually. So I guess a lot of people are following me, and really thank you for your support, and thank you for giving me a lot of recognitions actually. I'll try to post more videos. Due to the work-life balance, I'm not in a position to put a lot of videos in daily basis, so I'm trying my best to put videos and to give better informations in this video. So I will meet you in another fantastic video. Until then, bye from Subhash Chandran.